Question 6. The diagram shows the curve y equals x to the power 4 minus 8x. Let's line that up a bit nicely. Part 1. By sketching a second curve on the copy of the diagram, show that the curve x to the power 4 plus x squared minus 8x minus 9 equals 0. Has two real roots. State the equation of the second curve. Right, well, if we've got x to the 4 plus x squared minus 8x minus 9 equals 0, and we rearrange this, we would get x to the power 4 minus 8x on this side, which is what we started with, and on the other side we'd have 9 minus x squared. So the second curve that we're going to draw is this one here. If you just dive in and try and draw it, it's very likely you're going to make a mistake. Let's move that mouse out of the way, get rid of the red dot. So let's have a look at the roots of these two equations so that we know where these curves are going to cross the x-axis. I mean, we know roughly the shape of this. This is going to be an n-shaped parabola, so it's going to go up here like this somehow. But we don't know exactly where it's going to cross, and that's important to get all the marks for this question. So if we imagine x to the power 4 minus 8x equals 0, we can factorise that, which means we've got roots at x equals 0, well that's pretty obvious from the graph, but also at x cubed minus 8 equals 0, so x cubed equals 8 and x equals 2. So on the graph we've got 0, and this point here, this is really difficult when you haven't got the graph on your paper, is 2. Second curve, we've got 9 minus x squared. Let's find the roots of that. Well, that means that x squared equals 9, so x is plus or minus 3. So we've got minus 3 over here where it's going to cross through, and plus 3 somewhere around here, let's say. We've got an n-shaped parabola, so let's say it's going to come up this way like this. It should be roughly symmetrical, and it's going to come round there. It's not showing up very well. Oh no, let's try again. It's going to come up here and go down there. Okay, you'll actually be able to see the curve you're drawing it against, so yours should hopefully be a little bit more accurate than mine. The important thing is though that this point here is in the upper right quadrant and not crossing somewhere down here. Okay, so that's the end of part 1. Question 6, part 2. The larger root of the equation x to the power 4 plus x squared minus 8x minus 9 equals 0 is denoted by alpha. Show by calculation that alpha is between 2.1 and 2.2. So if we want to show a root is between two numbers and it's a continuous function, if we substitute those two numbers in and the answer of one is positive and the answer of the other is negative, then we know somewhere between those two values the answer must be 0, and therefore there's a root. So we're going to do f of 2.1, which just means substitute 2.1 in for x. And if we do that, we get minus 1.9419. So this one's negative. If we do f of 2.2, so 2.2 to the 4 plus 2.2 squared minus 8 lots of 2.2 minus 9, we get 1.6651. So somewhere between 2.1 and 2.2, this will keep getting closer to 0, it hits 0 and then it will get positive. There must be a root. That only works if your function is continuous. Okay, so we'll finish this question by saying, by the sign change rule, there is a root alpha where 2.1 is less than alpha is less than 2.2. Moving on to question 6, part 2, part B. use an iterative process based on the equation x equals the fourth root of 9 plus 8x minus x squared with a suitable starting value to find alpha correct to 3 decimal places. Give the result of each step of the iterative process. So, this question doesn't ask us to do that, but if we rearrange this formula, we can actually get this. Okay, so we'll start there by saying x equals the fourth root of 9 plus 8x minus x squared. Okay, we know that the roots between 2.1 and 2.2, so we're going to use a decimal iterative process to solve this. So we're going to say x naught equals 2.15. It's halfway between 2.1 and 2.2. So all we're going to keep doing is substituting this value into here, getting an answer, and then substituting the answer back in until we get two answers that are the same to the level of accuracy we want, which in this case is 3 decimal places. So when we substitute x naught into here, we would get 2.15526. Okay, so let's just write down what we did there. We did x1 equals fourth root of 9 plus 8 lots of 2.15 minus 2.15 squared. Okay, I'm not going to write that down for each time. I'm just going to assume that's what I'm doing. So now this answer, I'm going to substitute that back into here for x2, and I get 2.15574. Okay, if I do x3, I get 2.15579. So the fourth decimal place is the same this time, so I'm going to stop there, and my answer is going to be 2.156. Remember to round up here. And that's part B.